image. Okay, like from dark to blue. Okay, like from daylight to moonlight. Okay, like there are filters now in Instagram or Snapchats. We will be studying about that as well, like how you are changing the image, the visual image interpretation. Okay, then further, I will be giving you a brief idea about the Python libraries, not practically because the session time is short. Okay. I will be just giving you overview which libraries you can utilize for the image processing. Okay. Uh, Further, everything is clear. Like your fulfillment is complete. Like the session for which you guys have joined today is completed or not. If you want anything else, I will edit. Okay. Okay. Try to be very interactive, guys. Ask questions, just raise your hand, okay, or unmute yourself. I will be answering it. Okay. Okay. Then. Okay. Now, firstly, what is remote sensing? Okay, concept of remote sensing. Okay, I will be dedicating my 70% of this session on this particular topic. Okay, because this is important. If you don't know about remote sensing, you cannot jump directly on to visualizing our image. Okay, this is important. Okay, what is remote sensing? Okay, so under this, we have four things, four major components, which are like definition of remote sensing, which is really important. Okay, if you don't understand the definition of remote sensing, you cannot go further. Okay, then the source of energy, from where we are getting the image. Okay, like there is a saying now that if there is nothing in the room, there is dark. Okay, like light is the only source of energy. Okay, so from the light only we are visualizing a picture, the image. Like if you're looking at me, okay, you're looking because there is a light which is coming onto my face. Okay, this is the only reason you guys are able to look at me. But if I put a finger on the camera screen, you're not able to see me because the light is not coming. But if you see, the finger is also showing some red colors. Why it is showing some red colors? Because it is getting some absorption from the surrounding. Okay, the fingertip is getting absorption from the surrounding, and due to which there is a color which is red color. And why this red color is being absorbed, we will be studying about that as well. Okay, there is a pattern RGB. Okay, so this is red color, like this red color, na? Understand now? Okay, so this is how we are going to study about absorption, reflection, and radiation. Okay, these are the very basic component due to which a image is being captured. Okay, then further the interaction with the atmosphere, the interaction with the target. Okay, this we are going to study. Okay, so firstly, what is remote sensing? Anyone want to answer this? What is remote sensing? Yeah, guys, getting properties of something without actually touching physical contact with it. Good, wonderful. Others? Yeah, guys, please speak up. Okay, your definition can be wrong, but we are here to learn now. Everyone is here to learn. Okay, no one is going to judge you. Okay, so please open up your open up your fingers. Okay, yeah, I'm waiting still. Okay, just to break down this word, remote and sensing. What is remote? The remote. This remote is not remote. Okay, like this is a different remote. Okay, I'm talking about remote. Okay, in English, what does remote means? Not a technological perspective. What is mean by remote? Okay, let's see.
Controlling something.
No, 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 no. That is a definition which we are going in a like a technological perspective. Okay, but that is also correct. Okay, in journal in English, remote means far away. Okay, like we are having this session remotely. Okay, like you guys are sitting at your home, you guys are sitting at your colleges, someone is sitting at like far from the country as well. Okay, I have seen there was a international student. Okay, so this is a true definition of remote. Okay, like you guys are not nearby me, but you are away from me. Okay, far away from me. Okay, that is remote. Okay, you guys are watching me remotely. Okay, and this is also an example of remote sensing, that my camera is sensing the visual interpretation of myself, and it is transferring to you. Okay, this is exactly how the satellite works. Okay, like the camera which is working currently, this is how exactly the satellite works. Okay, so the meaning of remote is clear. Far away. Okay, like you guys are sitting far away from me, this is remote. Okay, then sensing. Okay, sensing means observing some information. Okay, observing some information. Like what type of information? Like if the camera which is looking at me is having some information that this person is having two eyes, okay, not three eyes, having a one nose, okay, having some mustaches, okay, okay, having some hairs, okay. So this is about the information the camera is giving to you, okay, but from a remote distance, okay, because I am not very close to the camera. The distance between camera is me is around 60 centimeters, 60 to 70 centimeters, okay, but still the camera is able to observe me and give you the detailed information about myself, okay. So this is what is known as sensing, okay. And the definition which is given by Ashutosh, getting properties of something without actually touching, okay, means a remote sensing, okay. Like you are getting my properties, what am I, okay. Or let's say you are having some, like some book, okay, this is a book, okay, you are having a book, okay. So you know this book is a rectangular in shape, okay, this book color is green, somewhere light white, okay, somewhere light green, somewhere dark green, okay. So you are having an information, so your camera is capable of getting the information about this particular object, but still it is not able to recognize this is a book or this is a piece of wood or something else. This we will realize by running some algorithms, okay, by running some proper algorithms through which we will able to identify, yeah, this is a book. How? We will check the density of this particular material, okay, because when your rays are like interaction with the target, there was a topic, okay. So when the top interaction is going to with the target, so it is going to check the density of this material. When the density of the material is being checked, it will find the density is of paper. The paper density is around 2 point something, okay. So density of paper will be identified, and then you can comment that this is a book, okay. So simply this is how remote sensing works, okay. Remote means far away, sensing means observing some information, okay. Everything is clear till now? Yes or no? Yes or no, guys?
Yes, sir.
Okay, good, wonderful. Okay, now definition of remote sensing. Remote sensing means acquiring some information of things from a distance. Okay. Now, this word distance, we will talk about this as well. Okay. Because each and every word which is present in definition should be clear. Remote sensing, it is clear to us. It is acquiring some information. It is clear. Okay. Of which, of some particular things or object. Okay. From a distance. But this particular point is not clear. Like what is the distance? 60 centimeter, 20 centimeter, 1 kilometer, 1,000 kilometer. Okay, this we have to clear. Okay, just wait and watch. Okay, but before that, just see yourself. Okay, human body is also having five senses. Your ear is the first example of it, your hand, your tongue, your eyes, your nose. Okay, but out of these only three are the basic example of remote sensing and other two are not the example of remote sensing. Can anyone tell me? Three are the pure example of remote sensing, but two are not the example of remote sensing. Yeah, guys, just think and look at the particular. See, we don't have to touch anything in remote sensing. This is the important point. So out of this, which is the tongue? Yeah, good, good, Hari. Touch and taste, good. Hand and tongue, good, 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 guys. Okay, yeah, audience is good. Okay, so hand and tongue. Okay, because when you are using a hand, you are going to touch something. Okay, you are going to touch something. Okay, and while you are touching, that is not a remote sensing. That is known as in situ experiment. Okay, Adi sir, what is this in situ experiment means? Okay, we will touch upon this as well. Okay, but before this, then you have your tongue. Tongue is also touching something, like you are having a sweet, okay, you are having a dessert, okay, you are tasting it, okay, your tongue has some taste buds, okay, like around five taste buds are there, okay. So your tongue is also tasting it, but your eyes are not looking at this, okay, like your eyes are sensing it. If you're looking at me, if you're looking at your laptop screen or a mobile screen, you're looking at the screen and you are sensing it without going closer or without touching the your screen. Your nose, like something is cooking into your kitchen, okay, like your mother is cooking something in your kitchen or something is being cooking in your canteen, you guys can smell it, okay, like This is almost a lunch time. Okay, you guys can smell this of any particular thing. Okay, like samosas, chole bhature, anything. Okay, then hearing. Hearing is also a form of remote sensing. Like you can hear to me very clearly. Is it clear to now or not? Okay. Now, what is in situ means? In situ means going and onto that particular position. Like ISRO has conducted several experiments which are in situ experiments, which was the example of Chandrayaan 3. Okay. Chandrayaan 3 was the example in which there was 1 second. So this is your Chandrayaan. Okay. You guys can see now. Okay. So this is okay. I'm just pinning up this screen so you can see this here. Okay. So this is your Chandrayaan. Okay. This is your Chandrayaan. Okay. In which we are having a lander. Okay. In this you are having a lander. Okay. So this is your rover. Sorry, rover. This is your lander. Okay. Your lander is landed onto some surface. Then your rover is coming out of this. Okay. The rover is coming out of this. Okay. And this rover. Okay. This rover is going to conduct the test onto that surface. Okay. Like this is the surface. Okay. So onto this surface, this rover is going to conduct some test. Okay. Like what Chandrayaan 3 did. They have a sample test of a temperature. Okay. Like they digged something around 20 centimeter and they tested the lunar soil. Another thing they did, they tested the seismic activities. Okay, lunar seismic activities. Okay, so this is because of the in situ experiments. Okay, so this is the example of a in situ experiment, which is going onto the surface and touching it and then getting it. But in the Chandrayaan itself, we were having Chandrayaan 1. Okay, this is Chandrayaan 1. Okay, this was a completely a remote sensing thing. Okay, into this, what happened? It was happening. It was hovering over the surface of lunar. Okay, it was hovering over the lunar surface. Okay, and while hovering over to the lunar surface, it collected and created a 3D atlas for the Chandrayaan 3 mission or Chandrayaan 2 mission. Okay, so this was Chandrayaan 1 mission in which this is completely a orbital mission in which it has having some cameras, okay, and a lunar imager, okay, which is continuously making the 3D atlas of the lunar surface. Like how it was decided that we have to land onto this surface. It was decided because of this remote sensing Chandrayaan 1 experiment. Okay. So this is how it was decided. Okay. And further, there was experimental thing which was done by ISRO, and it is done by ISRO frequently with their missions that they just landed, they did a crash landing onto a surface where they find the water, okay, water molecules. Okay. So this is about Chandrayaan 1, which was a remote sensing uh, mission, okay, in which it created a 3D atlas for the further upcoming mission. Okay, so we don't have to go to NASA, we don't have to go to ESA for asking the 3D atlas of the moon. We already have 3D atlas of the moon now. Okay, so this is how Chandrayaan 1 helped Chandrayaan 2 and Chandrayaan 3 subsequently. Okay, so now it is very clear what is remote sensing and how our body is also a good example of remote sensing. Just thumbs up if it is clear. If it is not clear, just raise your hand. Clear to everyone? Okay, wonderful. Okay. Now, yeah, this is the same thing which is written over here. Okay, remote sensing is a reading process. Okay, like your eyes are acting as a sensor. Okay, like a visual sensor. Okay, like you have a CCD camera. Okay, uh, this is exactly the same thing. Okay, like your eyes are a camera, visual sensor. Okay, like your mobile phone have na some sensors. Okay, like cameras over here. Okay, so these is a similar example. Okay, and the data which your eyes are acquiring are in the form of some light. Okay, like I told you now. See, into this we have two models. Okay, like see, this is just a basic session. Okay, introductory session or exploratory session in which you are going to get an idea. You cannot acquire everything regarding remote sensing. Okay, this I am making very clear. Okay, so sure, everything. Okay, uh, yeah, where was okay. So when we are discussing about the light, okay, so there are two models. There is one particle model, there is one wave model. Okay, these were derived by Isaac Newton. Okay, so we are not going to discuss about that in detail. Okay, we are just going to discuss that when Isaac Newton take a prism, okay, and it passed a white light, we were having a spectrum of light, okay, like seven lights, okay. So due to that spectrum, okay, due to the electromagnetic spectrum, we are able to see everything around us, okay. Like if I am able to identify a blue color, if I am able to identify a green color, this is because of a white light and my eyes, which are able to uh, segregate that this light is this color, this light is of this color. Okay, like we have roads and cones, which you guys have studied in class 10th and 12th. We have roads and cones in our eyes, due to which we are able to identify any color. And those people who are color blind, they have very less amount of roads and cones. Okay, and this is natural. Okay, this is natural. Okay, so due to this, we are able to see anything, and this property is when you are designing a particular sensor. Okay, so this is a very important point and to focus in. Okay, like when you are designing a particular sensor, we have to focus it. Okay, that we have to put a property that it is going to have a color sensing ability. Okay, like if you're designing it for the forest purpose or agriculture purpose, then the major color which you're going to see is the green color. Yes or no? Green color or blue color, the water. Okay, so the green color property should be available in your sensor. If your sensor is not able to read the green color, your data is not going to be produced. Okay, yeah, Mahek. Okay, so this is how you have to be very careful when you are designing a particular sensor as well. Okay, so this is an example for the remote sensing as your eyes. Okay, now what is geospatial science? Okay, geospatial science is studying about the mother earth. Okay, like why we have designed this technology, remote sensing, satellite imagery, because we want to study our mother earth. Okay, and for this there is a quote. Okay, there is a quote which was written by Socrates in 400 BC, that man must rise above the earth to the top of the atmosphere and beyond, for only thus will he fully understand the world in which he lives. Okay, so this was given in 400 BC, guys. Okay, that if you want to know about our mother earth, that when it is going to rain, like in UP, Uttar Pradesh, today it is almost raining everywhere. Okay, so you get a notification on your mobile phone that today it is going to rain. Okay, today the weather is hot. Okay, today it is going to be cloudy. So how you are getting this data? This is data is being given to you with the help of a satellite, which is in the sky. Okay, which is in the space, not in sky, which is in the space. Okay, so this is a clean example of remote sensing. Okay, and this is why we created a technology which is known as remote sensing and further satellite imagery. Okay, and now there is a quiz for you guys. Okay, give me a definition. Okay, technical definition or description of remote sensing in the chat section, or just raise your hand, I will call you. And this you have to answer it. Okay, this you have to answer this. Yeah, guys, a technical definition about remote sensing. We have cleared studied about remote sensing in a very detailed format. Now you have to answer this. Yeah, guys, anyone? Peter, Aditya, Ayush, Hari, Harsh. We have a lot of people. Yeah, just answer it. It is easy. Observing data from far distance. Good. Remote sensing has to be do with obtaining data about afar. Good. Good. Good, guys. Others, see, if you are able to answer this now, at the moment, you will remember it for your life. Okay, you don't have to revise or you don't have to revisit it. Okay. Okay, guys. Okay, let's move forward. Okay. So remote sensing is acquiring information of things from a distance. Okay. Now I told you I will discuss about distance. Okay. Distance. Okay. See, distance is defined when you have a particular application in your mind. Okay. Like agriculture. Okay. Or let's say agriculture for a minute. Okay. In agriculture, you must be in the low Earth orbit. Okay. You should not go away from the low Earth orbit. Okay. Low Earth orbit means 400 to 500 kilometer of altitude. Then only you are able to get a pure classification of the image. Okay, but if you, let's say, are in 200 kilometers or 250 kilometers, you will get a good image. Okay, but that image can have some defects. Okay, what are the defects? Like when you're going to interact with the, like, let's say this is how you are transferring some signal. Okay, so into this there is an atmosphere in between. Okay, like your vacuum is there firstly at first place, then there is atmosphere which starts in earth. In earth now we have atmosphere. Okay, yeah, distance is a relative thing. Okay, it depends on the application on which you are working. Okay, so as a engineer, as a scientist, distance you have to calculate. Okay, there are certain parameters on which you have to calculate the distance. For agriculture there will be a different distance. For ocean, like if you are focusing on marine lives, on marine horticultures and something like that. Okay, so you have to focus on a different perspective of distance. Let's say you are focusing on minings. Okay, you are focusing on defense area, then there is a different thing. You have to be in very low earth orbit. You don't have to go into 400 kilometers. You have to be in 100 kilometer or 200 kilometer, because this is a defense point. Okay, because there is a outer space treaty. Okay, like you cannot go beyond 300 to 400 kilometer when you're working in a defense domain. Okay, if you go, you can be easily identified. Okay, this is a simple thing. Okay, if you go beyond 300 to 400 kilometer, you will be easily identified by the other satellites. Okay, like let's say everyone has seen the movie Parmanu, na, in which we were having a Lacrosse satellite by NASA, which is in the space. Okay, and it was continuously taking the image of our. But why we were not able to counter it? That why your satellite is in the space? Okay, let me give you a brief idea. Okay, like let me go and give you an idea about this. Okay, let me just open it. Okay, how many of you are aware of outer space treaty? Just raise your hand. Outer space treaty is a basic law which is being followed by everyone. Okay, it has been drafted by United Nations. Okay, so I'm just presenting it for you guys. Okay, so this is the outer space treaty. Okay, so under this, if you go on to Article 1, okay, so Article 1, the exploration and use of outer space, including moon and other celestial body. Other celestial body means your Earth as well. Okay, shall be carried out for the benefit and interest of all countries, irrespective of their degree of economic and scientific development. Okay, means anything which you are doing in the space should be focused onto the mankind development. Okay, for the mankind, for the humanity. Okay, and other point, if you study it, okay, like this one, there shall be freedom of scientific investigation in outer space. Okay, or if you go and study about the third article, okay, you cannot do any other illegal activities. Okay, or these are known as the anti-satellites. Okay, Lacrosse is an anti-satellite. Okay, you cannot do any illegal activities. Okay, like you cannot carry a nuclear weapon, you cannot install a weapon into your satellite. Okay, you cannot do any such type of activities in this space. Like people are na, like there are some fascinating movies or something like that. You are having a nuclear weapon, you are going to destroy an asteroid with a nuclear thing. This is against the law. Okay, this is against the law. Okay, if something is coming towards us, we have to take it. Okay, we have to take it. Like let's say if an asteroid is coming towards us, we have to take it. Okay, there is no such option to destroy it. Okay, because this is against the United Nations laws. Okay, and you cannot go against these laws. These are international laws. Okay, so if NASA is creating something, let's say you have listened about the NASA, there is a plan that if some asteroid came, they are going to just put up a missile in the space and that asteroid is going to be broken up. But in general, this cannot happen. This cannot happen. Okay, this is not a very good way of approaching to an asteroid, because if that asteroid is going to be broken up, it is going to put some damage into the space. Like maybe that particle is going towards moon, maybe that particle is going towards some other celestial body. It is going to damage that celestial body. Yeah, okay. It is not damaging us, but it is damaging other celestial bodies. So indirectly, you are destroying the space. Okay, so this is not allowed. as per the space laws. Okay, so you have to take care about this as well when you're designing some experiment, when you're designing some mission with regards to the space. Okay, now coming back. So when someone is saying something to you, na, be very alert, like what he or she is saying to you. Okay, it should be like verified. Okay, it should be verified. Okay, and most of the laws are being created by NASA itself. Okay, because they are the leading player into this. Okay, like Artemis Accord. Okay, I will discuss about this at later point. Okay, okay. See, it can cause damage to life and infrastructure, but that is not your property, na. Asteroid is not your property. It is a natural phenomena. Okay, it is coming towards you. It is a natural phenomena. Okay, so this will come towards you. Okay, dinosaurs also extend, na. We are humans just. Okay, we can also extend one day. Okay, there is no such point of uh, discussion that we will putting a missile into the space and the asteroid will go away. Other asteroids will come. Yeah, hundreds of asteroids will come. Okay, what we will do? Okay, we cannot create a cage around us. Okay, this has been in the fictional movies. Okay, that we can create a cage around the earth or something like that. Okay, but this is seriously not possible. Okay, like for next 100 years, this is not possible. Okay, like till the period which I am living, this is not possible. Okay, because there is no such planning or this is no such discussion which is being carried out to create a certain cage or around something. This is not the plan. Okay, the plan is to study Earth. Okay, this is the plan which is going to be in the next few years. Okay, so distance point is clear now that for distance we have to take care of the application. What the application is: agriculture, ocean, marine life, etc. Okay. Now, there are two definitions with regards to the remote sensing. One is maxima definition and one is minima definition. Maxima definition was given by Hannes and Youngs in 1994, and the minima definition was given by NASA, which is obtaining information from an object without being in direct contact. Okay, this is the given by NASA. But the definition which is given by the Hannes and Young is very depth one. Okay, like when you're designing something, this definition is being utilized. Okay, like acquisition of information about the land, sea, and atmosphere. Where we are focusing on land, sea, and atmosphere. We are focusing on these 3 points. Na? So this definition is very clear in itself. And through which we are trying to focus in on through the sensors, imaging sensor, thermal sensors, or sounders, mappers, ultrasounds. Okay, so these are the sensors which we are using for these remote sensing application, and some distance at some distance from the target of study. Okay, it is very clear that from the target of study there should be a distance. Okay, so this is a maxima definition, and the minima definition is minima. Okay, obtaining information from an object without being in direct contact. Okay, so I hope maxima and minima definition is clear to everyone. Okay, now this was the concept of remote sensing. Okay, till now we have covered about the concept of remote sensing. Now, what is remote sensing process is actually? Okay, so should we go to the next part? It is clear to everyone what is the definition of remote sensing and what is remote sensing exactly? Good, guys. If you guys are not able to understand in English now, just raise your hand. I only know Hindi, okay, apart from English, okay. So if you're not able to understand in English, I can explain you in Hindi as well, okay. Okay, guys. Now, remote sensing process, okay. So there are 7 components in remote sensing process. First one is the energy source, which we are going to discuss in detail, okay. Second is the radiation. Third is the target. Target is obvious now, okay. Target will be there. Okay, we have to study a target. Okay, and how we have to study a target? Through a sensor. Okay, and how the sensor is going to give the data to the ground station? Through a communication channel. Okay, which are going to process it. Okay, then further, when the communication channel has received, the ground station has received it, they further go to the analysis part. Okay, then further we can derive the application out of it. Okay, so this is a brief overview of remote sensing process. Okay, now let us see in the detail way. Okay, so these are the 7 components. Okay, A, B, okay, C, D, E, F, G. Okay, so A is the illumination. Illumination. What is illumination? Illumination is like something is brightening. Okay, Like let's say this particular light, okay, this is light which is coming towards you. It is a form of illumination. Okay, so this is measured in lumen. Okay, this is measured in lumen, 100 lumens, 20 lumens. Okay, this is in vacuum. Okay, we are talking about this in vacuum. Okay, this is not on the ground. Okay, I've written it clearly, vacuum. Okay, so over there you will be having sun as the major source. Okay, sun will be a major source of energy in the vacuum. Okay, no other sources. You can have moon as well. Like moon is also giving its energy from the sun itself. Okay, but sun is the major source of energy in the vacuum or in the space. Okay, so from there you are coming towards, like, focus on to this point. Okay, just let's study about this. Okay, and I have a bigger picture over there. Okay, so after a point is been achieved, like you have received the your source of energy, then further you are going to travel it. Okay, you are going to travel it. Okay, from where you are going to travel, the vacuum is over. Now you are going to enter into the earth. Earth has some atmosphere. Okay, earth has some atmosphere. That atmosphere will having some composition of dust particles. It will have some composition of your carbon dioxide, nitrogen. Okay, these are the major gases which are present. Okay, then you're going to interact. You're coming towards the atmosphere. You have cleared the atmosphere. Now you're coming towards the target. Once you have reached the target, okay, at the C point, okay, then your sensor will have a recording. Recording of what? Recording of energy. And that energy recording is being directly sent to the sensor again. Okay, it's not directly sent to the your processing unit or transmission unit. It is sent after receiving onto the target, na, interacting with the target. It is again sent to the sensor. That जो मैंने लिया है वो सही है नहीं, means the particular amount of data which I have collected is correct or not. Okay, so this is again going to verify with the sensor. Then when the sensor has been verified, then it is coming directly to the communication unit or the transmission unit. Okay, it is going to receive this signal, then it is going to further process that signal. Okay, so TRP, which is transmission, receiving and processing, this TRP is different. Okay, transmission, receiving and processing, and this part is only in the satellite imagery. This is not in the drone imagery or the aircraft imagery. Okay, this is only in the satellite imagery. Okay, so transmission, like from the satellite, it is being transmitted. Okay, then it is being received at the ground station and it is being processed to the data scientist and the machine learning engineers. Okay, then further there will be an interpretation of the image which you have captured. Now there will be an interpretation of that image, that what is this image. Okay, what is present in this image. We will check about the density, we will check about the tone, we will check about the size, we will check about lot of other components. Okay, then further the application is being derived through which you can capture the other data and other information points. Okay, so this is pictorial representation. Like you are directly going to A, which is in the space, then B, the atmosphere, interaction with the atmosphere, C, interaction with the target, then again you are transmitting it. Okay, then transmission verifies, then again receiving, then further, what is the further process? TRP. What is the P? Speak up, guys. What is P?
Transmission,
Yeah, Peter. Yeah, what is P? Transmission, receiving and
receiving, and then
Processing.
processing. Wonderful. Okay, so we are processing. Okay, we are processing it. Then further, what is the next step? Analyzing it. Okay, analyzing it. Okay, then what is the next step? Final, the application. Okay, so energy source, illumination, we are getting it. Radiation and atmosphere, or the interaction with the atmosphere. Okay, this point can be interaction with the atmosphere as well. Okay, then interaction with the target, then the energy recording with the sensor, transmission, receiving and processing, TRP, and interpretation and analysis, and application. Okay, so this diagram should be very clear to everyone who is working or who is going to walk into this domain. Okay, because if it is clear, this is not a actual way. Okay, like a single engineer or a single scientist is not going to work on each and every point. Okay, Let me explain you more. Okay, like this satellite has been designed by several scientists: electronics, electrical, mechanical, computer science, every engineer. Okay, then further, this particular point, interaction with the atmosphere, this is being derived by a physicist. Okay, this cannot be this can be derived by engineer as well. Okay, but we are using a particle model or a wave model. Okay, so if we are using a particle and wave model, I think we should leave it to a physicist. Okay, because he or she is going to give or produce a good quality result. Okay, so the P point can be done by a physicist. C point can also be done by a physicist or an engineer. Then further points are done by data scientists. Okay, like those who know about Python libraries. Okay, those who know about certain algorithms. Those who know about the geospatial way. Okay, like geographical data, how to read a geographical data, like raster file. Okay, so these are the engineer which are involved at E and F point, and G point is the software engineer. Okay, like who is going to develop this particular system. Okay, and the sensor is being designed by electronics engineer or electrical engineer. Okay, so this particular process includes everyone from different domains. Okay, maybe you guys are from CS, you guys are from electronics, you guys are from mechanical also, like mechanical part is also involved. Okay, you guys are from civil engineering, because for the agriculture part or for the ocean part or for infrastructure development, we mostly require the civil engineers. Okay, because civil engineers can read the data very clearly. Okay, so we need civil engineers over there. Okay, so this particular picture shows the conjunction of each and every engineering domain in nutshell. Okay, so yeah, now what is source of energy? So, till now that particular image is clear to everyone? Yes or no? That image is clear to everyone? This image it is clear to everyone? Okay, now source of energy is basically your light. Okay, your visible light, which you can see through a prism. Okay, this was derived by Isaac Newton. Okay, so how does this happens? Okay, you have different forms of spectrum like radio waves, microwaves, infrared, ultraviolet, x-rays, gamma rays. Okay, majorly in remote sensing you are utilizing radio waves or microwaves. Okay, somewhat of the infrared waves. Okay, you're not going on to the your x-rays or gamma rays. Okay, mostly why? Because the atmospheric density at radio waves, microwaves, and infrared waves is much lower. Okay, like 10 to the power 6 hertz. Over here, it is 10 to the power 21 hertz. It is very high. Okay, so the density of the atmosphere is very high when you are talking with, or the weight of the uh, ray becomes very large. Okay, because if the weight is large of something, you cannot measure the things very properly. Okay, let's say I can give you a very brief example of this. Okay, let's say a human body. Okay, a human body is of 50 kg. Okay, it is very easy to lift a 50 kg human body. Okay, I'm talking about human body, I'm not talking about any other thing. Okay, so it is very easy to lift a 50 kg human body, but if that body is of 100 kg, of 200 kg, it is very difficult to carry that. Okay, because the weight is increasing, so that weight is not able to adapt with the atmosphere. Okay, this is a simple definition. The weight is not able to adapt with the atmosphere. If it is not able to adapt with the atmosphere, then what will happen? Simply, okay, you are not going to get more information about the atmosphere. Okay, but as a remote sensing application or a satellite imagery application, you require a lot of information about the atmosphere. Okay, so what you will do? Okay, what you will do? You will decrease the weight of the your ray. Okay, so you will be going into the, okay, 1 second. Okay, 1 second. Okay, so you will be going into the radio waves and the microwaves or the infrared waves for catching the most of the information. Okay, so this is clear to everyone that this is, I'm talking with design perspective. Okay, I'm not talking with some other perspective. Okay, this is with the design perspective. Okay, so when you're going to design something which this particular parameter. So you have to decrease the weight. Okay, you have to decrease the weight, and if you are decreasing the weight, you are going to enter into the radio waves, microwaves, and infrared waves. Not even ultraviolet. Okay, not you are not going into ultraviolet. Okay, and for Sauradeep, okay, see, हमारे पास एक बेसिक इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम है, ठीक है। हम लोगों को क्या करना है, उसके अंदर हमको इंफॉर्मेशन कैप्चर करनी है। तो इंफॉर्मेशन के लिए क्या करेंगे हम लोग, अगर हमारे पास वेट ज्यादा है, ठीक है, जैसे कि गामा रेस का वेट है 10⁻21, ओके, सो दिस इज वेरी हाई, ओके, ये बहुत ज्यादा है। सो हम लोग उसको वेट को रिड्यूस करेंगे, जिसके लिए हम लोग आएंगे लोअर स्पेक्ट्रम में, लोअर स्पेक्ट्रम विच इज रेडियो वेव्स। ओके, रेडियो वेव से हम अच्छा खासा इंफॉर्मेशन ले सकते हैं। लाइक हमको अगर कम्युनिकेशन करना है तो हम रेडियो वेव्स के थ्रू कर सकते हैं, हमको कोई ट्रांसमिट करना है सिग्नल, रेडियो वेव्स के थ्रू कर सकते हैं, और इवन वी कैन एंटर इनटू द माइक्रोवेव्स फॉर सेंडिंग अ थर्मल इमेज टू द योर सैटेलाइट। ओके, सो आई सपोज Sorry, your explanation is clear. Okay, so this is how we can enter into the lower spectrum when we want a good amount of information. Okay, so this is the basic definition, okay, about this electromagnetic spectrum. Okay, and when you're designing a sensor, okay, when you're designing a particular sensor, you have to utilize and you have to study about this electromagnetic spectrum, which is known as EMR. Okay, now so question, what is the maximum distance we can transmit with the radio signal available in the market? Okay, if you are talking about the general purpose sensors or general purpose component, electrical component, okay, the maximum distance is dependent on your application. Like maximum, like there is one LoRa module, okay, with that you can go up to 20 kilometer to 25 kilometer, okay, your radio signal, okay. But if you're designing it, you can go up to a 50 kilometer or 60 kilometer very easily, okay. So if you want to purchase it, you can go with the LoRa module. It is giving you around 20 to 25 kilometer. But again, that module is dependent on your design perspective, like the sensor which you are using, the wavelength which you are using, okay, the frequency which you are using, okay. So it is dependent, okay. So it can go up to 20 kilometer, okay. I have tested it, okay. It surely will go up to 20 kilometer, okay. Most of the cases there is an error, okay, so it will go around 15 kilometer, 12 kilometers, okay. So yeah, just check with the frequency or just check with your circuit if it is right or wrong, okay, then you will have the data, okay, proper data. Kahana, it is clear? Okay, so then see, if you have this image, okay, we're talking about TRP, okay, transmission, reception, and processing, okay. So this is a particular image which you can open up your Google Maps and you can see this image, okay. Just put it on satellite mode, okay, you can see this image, okay. You are having some green patches, okay, you are having some homes, okay, but can you identify there is a road or something like that? Yeah, can you identify any roads? Just look at. Yeah, guys, are you able to identify roads? Where is that image? One second, guys. Okay, I have missed that image. One second, guys. Okay, I think I have forgot to add that image into this. Okay, let me draw it for you. Okay, let me draw it for you. Okay, if you look at this particular point, okay, okay, so these are your roads. Okay, these are your roads. Okay, these red lines are your roads. Okay, so how you are able to identify this is a road or something like that? Okay, or this is a road. Okay, this is a flyover. This is a flyover. Okay, which is going across the particular green area. Okay, and this probably will be a village. Okay, this probably will be a village because this is having surrounding of a green area. Okay, and this is another highway which is crossing through it. Okay, this is another highway which is crossing through it. Okay, okay, this is another highway. Okay, and you can see there are several highways. This this will be a center of the city. Okay, this will be a center of a city which is having a ring type structure. Okay, a ring type structure. Okay, and this is having an interconnection of several roads. Okay, several roads over here. Okay, so this is another example. Okay, so if you look at this, this is being connected to a various things. Okay, like over here. Okay, over here, and this is connected to this particular point. Okay, so if I start from here, I can directly reach to the city. Okay, so this is what I want to give to you guys. Okay, uh, okay, I will come to your point. Okay, Kano, 1 second. Okay, so if you look at this particular point, how I'm able to identify this is a village or not, this particular patch is a village, because the surrounding is very green. Okay, if you look at this particular point, like I visualize this, that the legend. Okay, legend means the properties. Okay, so the grass is there. Okay, trees is there. Okay, like the ring road, na, which we see. This is a ring road. Okay, this is a ring road structure. Okay, there are trees, there are shrubs, there are bare soil. Okay, like bare soil means this is a bare soil. Okay, this is a bare soil. Okay, like khali land, which is of no use, dusty land. Okay, so this is a bare soil. Okay, and this is how you are able to define or interpret a particular image. Okay, now on the basis of this, you can craft a highway over here. Okay, this highway was not crafted without the help of a satellite imagery or a drone imagery. Okay, so you must have gone, the science engineers must have gone through a satellite imagery data, because how come they know that from here they can make a direct way to the city? No one knows this. Yeah, okay, if you start from here, it will be roughly around 50 kilometers. Okay, this will roughly around 50 kilometers. If you start from this point, now this particular point to this particular point, okay, this will be a 50 kilometers almost. Okay, so you never know that if you are creating this by hand, or this is you're creating with a local survey, you cannot create this type of structure. Okay, you will be causing some traffic or causing some defects. But with the help of a satellite imagery, you created a highway, then you connected it with certain roads. Okay, you diverted the traffic flow. See, you have diverted the traffic flow, then you again joined it. Okay, then further you are diagonally distributing the traffic. Okay, and then you are entering into the city. Okay, then you are entering into the city. Okay, so this is a basic and pure example of how satellite imagery is being used for the urban infrastructure development. Okay, so this is the example. Is that clear to everyone? How you can utilize your satellite imagery for this purpose? Okay, good, wonderful. Kana, I will come to your question at the end. Okay, just remind me. Okay, I will come. I will answer this. Okay. Okay. So this is how you read a data. Okay. Further, this is a different thing. Okay, like a very compressed image. Okay, a compressed image. Okay, this is the same image. Okay, this is the same image. This is a ring road again. Okay, which you are seeing. Okay, ring road. Okay, this is the same image. But now I have done another set of analysis in which I have found that which is a point where I can get certain data, like the patches where there are homes. Okay, so the homes are being redirected with a red color. Okay, dark red color. Okay, so you have a data regarding homes. Now there is a color which is light orange also. Okay, this is a light orange color. Okay, this particular let me change the pan. Okay, so this particular color, it is a light orange. Okay, this particular color is a light orange. This light orange color is giving you idea that the size of the houses is small into this particular region. Okay, like if you see over here, the sizes of the houses is small. Okay, like in this region. Okay, like the sizes of the houses is very small. Okay, but the sizes over here is quite good. Okay, quite good. Okay, this is a quite good house. Okay, this is also a quite good house. Okay, so this is because of a satellite imagery. Okay, this is because of a satellite imagery. And I have done this barren land or empty land with a blue color, so that I can get an idea that this is a perfect blue land. Okay, and there is no such house, there is no such vegetation, or there is no such other things. Okay, So this is an example. Okay. Over here also we have some few barren lands. Okay. Over here also there is a patch. Okay, which you can study. But if you see over here, you cannot get directly this particular image. Okay, this particular image. Okay. Over here you cannot directly see, but there is an image. Okay, this is a particular thing you can see. Okay. So this is the interpretation which you can do with the help of a satellite imagery. Okay. See, the duration of this session is very short to give you an idea how which we are getting this particular image. Okay, if you want to explore this, there is a software which is known as QGIS. Okay, QGIS. Okay, just go to that software or Google Earth. Okay, you can utilize Google Earth as well. Okay, I have utilized Google Earth. Okay, so with the help of Google Earth, okay, this is a lidar sensor. Okay, lidar sensor, or you can go directly to the Bhuvan platform by ISRO. Okay, Bhuvan platform by ISRO, and you can check it over there. Okay, you will get wonderful images over there, and you can analyze this. Okay, now further, if you look at this another example, okay, for checking the vegetation. Okay, like where there is a green vegetation, there is a stress vegetation, there is a dry vegetation. Okay, like there is a three category in which we have divided. Okay, green vegetation means like we are distributing in a area where you can do a farming or you can cultivate some sort of a crop or any small plants. Okay, stress vegetation is a point which is nearly going to the barren land. Barren land means almost it is not going to be fertile after a certain period of time, like 2 months or 3 months. Okay, this is a stress vegetation in which you can plant some cactus, okay, or some very grassy things. Okay, you can do these things. Okay, and there is a dry vegetation which is gone towards the barren land. Okay, which is becoming a barren land in 1 month, hardly 1 month it will take to become a barren land. Okay, unto this blue region there will be no grass substance. In stress vegetation you can find some grassy substance. Okay, like you can go nearby your locality, you can find this particular example. If you go nearby you, you will find that green vegetation is purely present. Okay, like you are passing through an highway na? Just look at this highway, the sideways. Okay, green vegetation is present, stress vegetation is present, dry vegetation is present. Okay, you have to observe this. Stress vegetation is an area where there is very little to some plants or some crops are being planted over there. Okay, green vegetation is a pure grassy area or there is a crop. Okay, which is most fertile. Dry vegetation is an area where there is a very less fertility. Okay, so this is a basic example you can do with the help of remote sensing or satellite imaging. Okay, so yeah, this is again a good example through which you can identify. Okay, and this is the data which is being used for the farming purpose, agriculture purpose, because in India 52% of the people are into exposed into agriculture. Okay, this is a very good data or a strange data that 52% of the people are being involved into the agriculture. Okay, and from where we are having our afternoon lunch or the dinner in the night or anything in the morning with the breakfast, everything is coming through the these farms or the agriculture lands. Okay, so we as an engineer has a huge responsibility to develop a technology that can help the farmers, then can help the agriculture land to grow more. Okay, to grow more. How you can develop this dry vegetation to stress vegetation and stress vegetation to green vegetation? You have to give them this particular idea. Okay, because as a farmer, the person is just going to ignore this fact. Okay, because the farmer is not going to be that much bothered about what is happening with his land. Okay, he's just bothered about the crop which is bowing down. Okay, it will give him hardly some rupees. Okay, like let's say 5,000 or 10,000 rupees if it is a small patch of land. Okay, by selling some crops. Okay, so why he will be bothered about utilizing your technology which is worth rupees lakhs or crores? Okay, so now here government comes into the picture. Okay, or the ISRO comes into the picture. ISRO and the local panchayati grams. Okay, In India, we have local panchayati grams. Okay, those are international students. Okay, so the panchayati grams, what they did, they provide this data to the farmers that this is the duration where you can convert your dry vegetation to stress vegetation. Okay, like the sun heat will be very low, the rain will be there. Okay, so you can cultivate some crops where you can utilize it. Okay, and you can have very good results. Okay, so this is how government helps the farmers. Okay, not in farmer bills, but yeah, in the technological perspective, the government do helps. Okay, talking about the application is huge, from agriculture monitoring to urban infrastructure to weather monitoring, typical chlorophyll concentration monitoring. Okay, this is a good example. Okay, this is a good example. Okay, like how uh, mostly you guys have consumed omega 3 in your life. Once in a life, you have consumed omega 3. Okay, and that comes from fish. Okay, that comes from fish. So maybe it is a cosmetic way. Okay, like most of the cosmetic are also derived from fish oil. Okay, like the serums. Okay, like serums which you are using now. Okay, so that are derived from the fish oil itself. Okay, so fish plays a very huge role in your day-to-day life, like your maintaining your vitamins levels. Okay, or if someone is having fish in their food. Okay, that is another topic. Okay, but the fisherman who catches this fish, they have to get an idea of when to catch a fish, because every time you cannot catch a fish. Okay, so if you look at this particularly, okay, I can zoom it. Okay, yeah. So this particular red region, okay, this red region is a region where you are having a huge amount of chlorophyll. Okay, so if you go there, you can catch fishes very easily. Okay, you can catch fishes very easily. Okay, so this is an example for that particular thing. Okay, so if you are having fish, if you are having some proteins in your diet, we can thanks to the satellites. Okay, we can thanks to the satellites which are in the space. Okay, then the forest fire. Yeah, obviously we can monitor forest fire and we can help them stop it. Okay, the flood damage. Okay, we can analyze the flood damage or any natural disaster. Okay, like there was a natural disaster a few months back. Okay, so we can identify a natural disaster. Okay, like the monsoon season has started. Okay, there will be surely a natural disaster in the hilly areas. Okay, like in Himachal Pradesh or Uttarakhand. Okay, there will be some natural disasters. Okay, so these disasters are predicted way before the occurrence. Okay, so people are not going to listen it. They are going to travel to the hilly areas, to the valleys, to watch the snowfall and to watch the uh, good views. Okay, but these been already been announced by ISRO. If you go to their website, okay, NRCL, okay, you can easily find it out. Okay, the disasters are already being announced. Okay, and the precaution is being taken by the government of India. Okay, but not from the common peoples. Okay, talking about volcano eruptions, yeah, volcano eruptions are also being monitored through the remote sensing or the satellite imagery. Okay, because volcanic eruption is plays a very huge role, because when volcanic eruption occurred, there is a huge earthquake. Okay, there is a huge earthquake which is being sensed. Okay, so volcanic eruptions are being monitored through a seismic unit. Okay, seismic department. Okay, as well as your remote sensing department. Okay, both departments are involved in the volcanic eruption monitoring. Okay, so this was with regards to the applications. Okay, now till here everything is clear to everyone. Yes or no? Just thumbs up if it is clear to everyone. Ayush, Raghi, okay, good. Now, interaction with the atmosphere. We already discussed this interaction with the atmosphere, that what is going to happen with the atmosphere. Okay, like there is an absorption. Okay, like when something is falling towards you, you will be having an absorption. Okay, you will be having absorption. Like there are some dust particle. Here also, like I am sitting in a very clean room. Okay, but this room will also have some dust particle around it. Okay, so that dust particle are absorbing this light wave. Okay, let's say there is a light wave which is coming towards us. Okay, this is a light wave which is coming towards us. Okay, so this has been absorbed. Okay, this has been absorbed. Okay, like if it is very clean. Okay, and if you pass through it. Okay, and if you see this in microscope, you will find that there are some dust particles which are accumulated onto the surface of this particular thing. Okay, and this happens with the normal signal, the sensor which sensor is transmitting towards you. Okay, then scattering. Scattering is a phenomena which, yeah, this is a basic definition. Who is going to answer this? What is scattering? What is scattering, guys? I was answering everything. What is scattering now? Hari? Yeah, Peter.
Okay. Scattering is a phenomenon in which light passing through an object doesn't go in a straight way. In a straight way, example is a colloidal particle, a colloidal substance, in which the light particle is being scattered due to some particles or molecules within it.
Okay. Path of light shown by dust particles, randomness of particles. Okay. Yeah. Scattering is a small process, okay, in which your particles, okay, which are in the atmosphere, okay, like the Brownian motion, you have studied about Brownian motion, okay. So which are in the atmosphere, okay, the particle get diffused, okay, they get attracted towards you, okay, in the incident direction, okay, like the direction which you're going up. So you create the path, okay, like which was mentioned by Hari, okay. So it I use, okay, so you create a path, okay, or you can, yeah, also known as canopy effect, okay, it is also known as canopy effect, okay. Then you have refraction, okay, you have refraction, okay. Let's look at with the examples, okay. So absorption basically is like you when just changing the color. See, when you're sending some short wave from the satellite, okay, this is coming from the satellite, okay. So it is being absorbed through your atmosphere, which is your greenhouse gases, okay, like carbon dioxide or the clouds, okay, in the atmosphere. Then this is directly coming downwards, okay. Then this is where the reflection is coming into the picture, okay, like it is being reflected, okay, through the mountains, okay. So it is being refracted and there is no such direction, okay. It can directly go into this direction as well, okay. So this is how you have to be very cautious when you are transmitting a signal towards the earth, okay. That that signal can go into either direction as well, okay. So you have to be very cautious with that, okay, while you're designing a sensor, okay. So cloud can reflect it, okay, the visible solar radiation, okay, microwave frequencies, okay, are used, okay. That's why I was saying that microwave or the your radio waves are used for this purpose, because they have a very less weight, so they can contain or they can adapt the other properties in the atmosphere, okay. So this is how absorption and reflection is taking into the picture. Then your refraction, okay, refraction is when you are transmitting an incident ray, okay, there is a medium, okay, like vacuum or some other medium, okay. So it gets refracted towards that, okay, it gets refracted towards that, okay. And I hope you guys have studied this in your class 12 in the optics, okay. This is very basic, okay. So this is a plain example of your refraction, okay. Reflection is simple, like you process in which your radiation is bouncing off, like mountains over here, mountains, it is bouncing off. Bouncing off in which direction is totally dependent on the design of your satellite. Okay. It totally depends on the design of the satellite. Okay. So this is another example. Okay. So this was interaction with the atmosphere. Atmospheric interaction is really important. Okay. To get an idea about the things. Okay. To get an idea about the things. Okay, guys. Now let's jump on to the ISRO payloads. Interaction of the atmosphere is clear. See, this particular part till here, everything is clear now. Like we have discussed about the interaction with the atmosphere and the interaction with the target. This is clear to everyone. Okay. Okay. I am not going to touch upon to this particular part. Okay, because this requires a certain software expertise. Okay, and also yeah, this part. Okay. Yeah, this part will be covered. Okay, this part will be covered. Okay. Now the ISRO payloads. Okay, so there are several payloads of ISRO. Okay, I will be sharing a handbook to with you. Okay, so she will be sharing with you guys. Okay, with regards to the ISRO payloads. Okay, there are several payloads of ISRO in remote sensing, and we should be very proud that India ISRO is the leading player in the remote sensing or the satellite imagery domain. Okay, we are really the number one in satellite imaging. And that is why NASA has come up to launch a collaborative mission, which is NISAR, okay, which is NISAR with ISRO, okay, because we are master in the remote sensing or the satellite imagery, which we can say, okay. So there is a first payload, okay, which is these are the experimental payloads, which are the Rohini satellite series, okay. These are successful payloads, okay, and the Bhaskar payload, okay. Bhaskar payload looks like this, okay. This is a Bhaskar payload, okay. So you can see, okay. This is a Bhaskar payload, okay, and along with the Bhaskar payload, okay. So this is almost a replica of Bhaskar payload, okay. Bhaskar payload was the first payload which was sent in 1969. Okay, and this objective of this Bhaskar payload was to study the Earth. Okay, there was several other objective, but it was basically for the study of Earth. Okay, and it was sent by the person who is in the photograph. Can anyone name this person? He is known as the Satellite Man of India. Yeah, guys, Satellite Man of India. Who is Satellite Man of India? He is UR Rao, sir. Okay. Udupi Ramachandran Rao, sir. Okay. On his name, there is a center of ISRO as well, UR Rao Satellite Center. Okay. So he was the person who designed the first ISRO satellite. Okay. Aryabhatta as well as Bhaskara. Okay. So this is the about Bhaskara, and the primary objective of Bhaskara is simple. Okay. To study about the meteorology and hydrology and forestry. Okay. With two band camera. Okay, what is two band camera now? Two band camera is utilizing a communication channel through which the camera is being connected. Okay, because at that early time we don't have certain technology of cameras. Okay, so what we did a jugadu method. Okay, okay, we created a two band TV camera system through which when we are transmitting something, okay, it is being stored on the ground. Okay, so we are getting another wavelength of frequency from the ground to charge that particular frequency and to send back again. Okay, so we were utilizing the ground station for charging our frequency in the space, and nowadays this has been happened directly in the space by the help of a orbiter or a communication payload. Okay, yeah, who is this? Sorry, Dipya.
Sir, I don't get it. The point. Two band TV camera system. Can you
Okay,
please
okay,
repeat
I'm
again
covering
in
it. Okay,
Hindi?
see, two band in general, na, like let me give you a brief example of it. Okay, if you take anything, okay, like let's say if you are having a basic communication band, okay, in that you have S band, you have K band. Okay, so what does a two band camera does? The two band camera does, they utilize the communication channel. Okay, they utilize the communication channel of S band or K band. At that time 1969 we don't have this technology that we can utilize this two band at a simultaneously, okay, like at the same time. Okay, so what we did, okay, what we did, we put a one band over here, like S band over here and S2 band over here. Okay, we were utilizing one band, but we divided into two parts, S1 and S2. Okay, so when S1 band is sending some signal towards Earth, S2 band is getting charged, and S2 band is sending some signal to S1, it is getting charged. Okay, so we were having a continuous signal. Okay, and in signaling systems, okay, if you go, this process is known as quantization process. Okay, because you are charging your bands continuously in a process. Okay, so this is your two band camera which was used at that time, but nowadays we are using a simple orbiter or a communication system, dedicated communication system, which is having a whole band, and we are having antennas nowadays, proper antennas. Okay, so this has been coming, but now at that time it was not present. Okay, so we were using a different set of technology which is known as a jugadu method, which Indians are very, okay, or which is known as in English frugal methods. Okay, frugal methods. Okay, now this is basically dedicated for the meteorological purpose, like your weather assessment. Okay, your other aspects. Okay, the hydrology, the forestry. Okay, because at that time we only need these things. Okay, like we want to have a set of application for the weather forecasting. Okay, because if we have application for the weather forecasting, most of our scientific missions are dependent on the weather forecasting itself. Okay, like for a launch of a satellite, for a launch of a payload, for the flights, the international flights or the domestic flights. Okay, we have to have a your local, like indigenous weather forecasting system. So the this particular satellite, okay, this particular satellite, okay, it created a weather forecasting system for India in 1969. Okay, and at that time there was Doordarshan channel, which was forecasting your weather for the whole day or for the whole week with the help of this meteorological satellite. Okay, so we should thank our scientists for this particular invention, and we should thank the technology which we is developed and which is improving day by day with our involvement. Okay, like maybe from you guys someone is going to improve this technology, or maybe you are going to create some inventions into this technology. Okay, so this is how we have a very important system, which is weather forecasting system with the help of a satellite imaging. Okay, now second objective was to conduct ocean surface study, because as a developing nation, okay, as a developing nation, we want to have your navy. Okay, we want to have some water deals, like the export and import deals. Okay, for this there is a very important need to study about the surface of your oceans. Okay, because we have information about the oceans, then only we can transmit it to the other nation that yeah, the way is clear, this is our boundary, this is our atlas. Okay, so this is very important. Okay, so this is how the Bhaskara payload, okay, which was the first payload, this was developed and it was very successful. Okay, it was very successful. The life was of 5 years, but it survived around 6.7 years. Okay, 6.6 years, 7 months. Okay, so this is one of the successful payload or successful satellite of India. Okay, then this is some detail about the Bhaskara. Okay, if you want to read, okay, after the session I will share this PPT. Okay, you can just go through this. Okay, and yeah, this is another satellite which is Cartosat. Okay, you can see the size of the satellites. Okay, the size. Okay, this is human. Okay, this is a scientist. Okay, scientist size and your satellite size. Okay, this is that huge. Okay, so this is a propulsion system. Okay, for those who are new. Okay, this is a propulsion system. Okay, these are solar panels, and over here your satellite is. Okay, over here your satellite is. Okay, this is going to get detached. Okay, this is going to get deployed. Okay, and you will be having your cartosat in space. Okay, so over here this is your cartosat. Okay, this is your cartosat. Okay, this one is your cartosat. Okay, and yeah. Okay, so Cartosat was basically designed for the urban management and disaster management. Okay, because at that time we were having a sufficient data with regards to the hydrology, forestry, and other things. Okay, so we want to have some urban management. We want to improve. Okay, we want to develop the things. Okay, so urban management, disaster management. Okay, environmental assessment. Okay, so this was the another thing which was done by the Cartosat one. Okay, with the help of your satellite image technology. Okay, so this is another example of your ISRO payloads. Okay, I will share a detailed PDF of remote sensing payloads of ISRO. Okay, you can study it. Okay, it is around 500 pages. Okay, you can study it. Okay, and if there is any doubt, okay, you can ask me. Okay, I will be dropping my mail ID. Okay, so you can ask me. Okay, now the visual image interpretation. Okay, till now we have discussed about remote sensing. We have discussed about how remote sensing is working. Interaction is happening. Okay, the case study, okay, like the about ISRO payloads. Now, visual image interpretation. Okay, visual image interpretation is simple. Okay, I have just made some few examples. Okay, through series of slides, you will be getting an idea. Okay, okay. So focus onto this point. Okay, this is important. Okay, this is very important. Okay, your energy. Okay, your energy is coming from sun. Basically, your energy is coming from sun. Okay, any energy which you are seeing around yourself is coming from sun itself. Okay, so energy, when it is coming from sun, it is being recorded by a sensor. Okay, because your sensor records energy. Okay, so what does it do? Okay, like let's say this is your satellite. Okay, this is your satellite in this space. Okay, and this is the platform. Okay, this is the target which you have to study. Okay, and over this target you are having some, let's say, green cultivation. Okay, So this satellite, what the satellite is going to do, the satellite is absorbing the energy of sun from the in the form of radiation. Okay, because what are the forms of heat transfer? Conduction, convection, and radiation. Okay, conduction cannot happen in vacuum, convection cannot happen in vacuum. Only left option is radiation. So through radiation, your sensors are getting energy, and this energy is being absorbed into the sensors. Okay, now what is the further step? Okay, when your energy is being absorbed in a sensor, okay, now there are some different wavelengths which we discussed about electromagnetic spectrum. Okay, so it will brief out, it will segregate into the electromagnetic spectrum like radio wave, microwaves, okay, ultraviolet, infrared, oh sorry, infrared, ultraviolet, and then further. Okay, so it is going to segregate, then further it is going to identify that which is best for me, okay, which is best suited for me. Let's say it is selected radio waves. Okay, so it is selected radio waves, then further that particular vegetation area, okay, this vegetation area, okay, it is going to reflect back. Okay, because now you have selected the weight of your wavelength. Okay, so that wavelength weight is going to interact with the target. Your interaction with the atmosphere is over. Now you are interacting with the target. So when you are interacting with the target, what is going to happen? Your wavelength is going to absorb the information. Okay, it is going to interact with it. Okay, so the information is being absorbed. Okay, when the information is being absorbed, okay, so there will be some changes in the wavelength, because when something is falling onto the surface, it will change the property. Simple example, if you take a water glass, okay, it is very clean water, pure water. Okay, and if you drop a droplet of a red color, okay, try it. Okay, try it at your home. If you drop a droplet of red color, okay, red color lies between your microwave and radio waves. Okay, if you're talking about spectrum. Okay, so that red color it will come slightly down. Okay, and it will start losing the density of the color. Okay, at the starting point, at the A point. Okay, let's say this is the A point. Okay, this is the A point. Okay, and this is the B point. Okay, so from A point to B point, the density of your liquid will be very low. Okay, because it has started absorbing the property of the surrounding. Okay, this is what I'm talking, because when you are interacting with the target, you are absorbing the property of the target now. Okay, so your property is going to change. Now you have the property of the target that, yeah, this is a vegetation area, so you are going to send back to the your system, your sensor. Okay, so this is how things are happening. Okay, so then there is a surrounding thing, there is a pool. Okay, you are having it like water. Okay, water is also reflecting some into the blue green spectrum. Okay, so there is a change in your, what do you say, in your spectrum. Okay, so this is how things happens. Okay, this is how things happens, and this is how you collect the data from the ground to the sensor which is present in the space. Okay, is it clear to everyone? This particular slides are clear to everyone, that how your satellite is being interacting and how it is getting the data and how the data is being getting absorbed and it is transmitting back to the your satellite. Okay, it is very simple, guys. It is very simple. Okay, it was tough before you entered into the class. Okay, but now after having into this particular session, it is easy. Okay, it is not tough anymore. Okay, now when we are talking about sensors, okay, there are two types of sensors: active sensors and passive sensors. Okay, passive sensor is where we are using the source energy. Okay, either the sun or the atmosphere. Okay, because atmosphere also has some energy. Okay, but when we're talking about active sensor, the source of energy is a part of remote sensors. Okay, like this is having a power supply. Okay, dedicated power supply, which is having an insulation. Okay, which is having an insulation, and we don't use active sensors. Okay, we don't use active sensor more. Okay, we only rely with the passive sensors. Where we use active sensors, this can be your questions. Okay, we use active sensors to study celestial objects like Mars. Okay, like Jupiter, like Venus. Okay, there is a mission which is planned for Venus. Okay, so we study the celestial object with the help of active sensors. Why? Because we don't want the interference of any other uh, body. Okay, any other energy source. Okay, like your sun or any other star or any dying star. Okay, we don't want their energy. Okay, we want to have a dedicated energy, because the power supply which you are designing for your satellite, it is a calculated power supply. Now you know about this power supply because you have designed it. Okay, it is 100 watts. 100 watts of what? Lithium ion battery. Okay, lithium ion battery has such properties. Okay, so you know about this property. Okay, so when you are calculating anything about satellite through a satellite, okay, of Venus, okay, so you can deduct it. Okay, you can subtract it and you can have a real data. Okay, you can have a real authentic data about that particular planet. Okay, so this is how satellite imagery happens. Okay, this is a wonderful, beautiful thing which you can do perform. Okay, this is very easy, guys. Okay, so this is about passive sensors and active sensors. Okay, there is only two type of remote sensor: passive and active. Okay, now till here everything is clear. Passive and active, and particular this slides. Okay, this particular slides. It is clear to everyone. Yes or no? Just thumbs up. Okay, we are having 20 minutes. Okay, so we will be having this. Okay, maybe we will be overshooting the time. Okay, by 10 minutes, but yeah, we will be covering everything. Okay, so types of resolution. Okay, we have basically simple resolution, spatial resolution, and temporal resolution. Okay, spatial resolution means like this particular image. Okay, look at this particular image. Okay, the size of this pixel. Okay, yeah, Peter.
Yes. Please, can we get the PDF of this?
Yeah, yeah, sure. I will share this. Okay, I will show this.
All right. Thank you very much.
Okay. Yeah. Okay. So spatial resolution. Okay. Firstly, what is resolution? Anyone can answer this? What is resolution? Yeah, Pragati. Okay, I will share. Okay. What is resolution? One resolution is like you take on your every new year. Okay, that I am going to gym. Okay, I am going to lose weight. I am going to study. Okay, I am going to get 90%. That resolution I'm not talking. Okay, because that cannot be fulfilled. Okay, I'm talking about a different resolution. What is this resolution, guys? This resolution is very easy to answer. Number of pixels in a frame. Okay, others. See, resolution means the level of detail. Okay, like the quantity of details which you are having. Okay, or the number of pixels. Okay, like how you are classifying that particular image. Okay, let's say someone has taken my like this particular block which is of my image. Okay, how it is identify that my color is this of this shape. Okay, or what is the shape of my face. Okay, so this is happening because of the pixels. Okay, pixels are reading. Okay, there will be pixels. Okay, like these are mapping my face. Okay, so number of pixels at a particular area, it is known as resolution. Okay, it's like you have 32 megapixel camera, 62 megapixel camera. Nowadays 100 megapixel cameras are also there. Okay, so these pixels are giving you high resolution image. Okay, like there is a high HDR, resolution image or high definition resolution. Okay, so this is because of this resolution. Okay, and in satellite imagery we have two types: spatial resolution and temporal resolution. What happens in spatial resolution? Images with small pixels. Okay, they have a very high resolution. Okay, they have a very high spatial resolution. Okay, so you can study them very easily. Okay, like if you see over this image, okay, you can study about this image very easily. Okay, this is in 1 into 1 meter. Okay, but when this image is zoomed in, okay, this is zoomed in. Okay, this is 4 by 4. You cannot read it very properly. Then again 20 into 20 spot. Okay, this is more zoom. Okay, you cannot read it. Okay, but you can read the blocks. Okay, you can read the blocks. Still you can read the blocks. Okay, that over here you will not have anything. Over at the blue surface you will have something. Okay, because these colors are defined on the basis of the information you are getting. Okay, so spatial resolution should be very small. Then only you will be able to read image in a very good way. Okay, so if you go with the definition, okay, images with small pixels are said to have a higher spatial resolution, okay, which lead to have a clear scenes, okay, or the clear image, okay, while images with smaller pixels have a lower spatial resolution, okay. So that's why we have good pixel images, okay, through a satellite. Now, tested with the temporal resolution. Temporal resolution is different, okay. Like you are capturing an image, your satellite is being onto a surface for a particular day or a particular month, okay. So for 16 days, your temporal resolution will be low. For 24 to 3 days, your temporal resolution will be high. Why high? Because when your duration is increasing, there will be certain defects which will be coming into the picture. Like there can be rain, there can be clouds, there can be dust, there can be anything. Okay. So due to this, what will have happen? There will be refraction errors. Refraction error. How refraction error will occur? Anyone can answer this? How refraction error will occur? Because when clouds are coming into the picture or any dust particle are coming into the picture, they will create a medium now. So when the medium is created, okay, your incident ray is going to refract, okay, due to density difference, okay. So your incident ray is going to refract, okay, into the other direction, okay. So it is important to have a satellite onto a surface for certain small period, not for a longer period, okay. Like people say na this, if we are on a surface we will gather more information. No, you will lose your information, you will destroy your information simply, okay. So if you are there for a very small period of time, okay, you can capture a very high quality amount of information through the temporal resolution, okay, which is known as temporal resolution, okay. This is simple, which you can implement in your day-to-day life, okay. Like you are here, okay, you are continuously listening to this from last 1.5 hour, okay, and if you go and study about this through a book, you will take around 16 days or more, 15 days, okay, because I have compressed the knowledge into 1.5 hour, okay. So this is a similar example of a teacher and a student, okay, because what a teacher does, teacher compress the information in a very small duration, okay, and a student does, he or she is going to start from the page 1. After this class, if you guys are going to study what is remote sensing, then you're wasting your time, okay, because that remote sensing concept has already been cleared. You should start with the second chapter, okay, application of remote sensing, the image interpretation, the resolution concepts, the multispectral hyperspectral concepts, okay. So this should be your timeline to study about remote sensing and satellite imagery further after this particular session, okay. So the conclusion from this temporal resolution is that if you are there for a very small period of time, you can capture a high quality and highly informative data. But if you are there for a very longer period of time, there will be defects, there will be certain parameters which are going to destroy your data, okay. So this is regarding the temporal resolution, okay. This is another example with the high temporal resolution, okay. You can have a use dynamics, okay, like for the changing environment, like there is a clouds or something like that, okay. So this is an image in where you have clouds, okay. So if you're there for few time, okay, like with the help of certain softwares, you can remove the clouds, okay, and you can have this beautiful image where you are having things, okay. But this image is being captured into this resolution, okay. This image is not captured into this resolution. These colors are being put by the scientist, okay, for their understanding, for their better understanding. And this is also another thing, like when you are using astronomy, okay, in astronomy also, the colors now you see of stars or any other things, these colors are being put by the scientist, okay. Space is not having color, okay, it is simple, space is not having colors, okay. There is nothing like a pink Milky Way galaxy, okay. Milky Way galaxy is looking like a dark Milky Way galaxy, okay. Milky Way galaxy is not pink, okay. Firstly, this should be your perception, okay. It is dark in color, okay, it is gray in color, okay. Your Andromeda galaxy is not in brown or something like that, okay. Your black hole or your wormhole is not brownish or golden color, okay, it is gray in color. These colors are being put by scientists and the engineers to study the image in a very good format, okay, and to engage you guys also, okay, because if you guys get fascinated through these images, okay, you will be able to study about these image, and maybe you can pursue a career into this. Okay, that's why these images are given some colors. Okay, like people say, there is an eye in this space. Okay, nature is being derived. Yeah, there is an eye, but that eye is of different color. Okay, so this is not exactly what you are having, a black color or brown color eyes in this space. No, it is a gray color thing. Okay, this is simple. Huh? You are just contradicting the theory of Isaac Newton and Albert Einstein. Okay, that in vacuum you are having colors. Okay, you cannot have a color in vacuum. Simple. Okay, just study it. Okay, you after this now just try to study about this. Okay, this is again a good example. Like further, this image can be taken into this. Okay, where you can identify potential sources of water. Okay, like where the water is. Okay, so you can have this like blue color is the water. Okay, and the patch, the strong patches and the weak patches. Okay, this is a strong patch. Okay, this is a strong patch, and these patches are weak patches because these are submerged into the water. Okay, these are submerged into the water. Maybe this is a algae collection. Okay, this is a algae collection, and also this one is also submerged water. Okay, so this is red in color. Okay, this is red in color, but this white patches are strong patches on which you can stand. Okay, so this is a remote sensing interpretation or a satellite imagery interpretation. Okay, now this slide is very important. Okay, because the defects. Okay, you guys are not asking questions, but I have already included it. Okay, what type of defect can be there? Okay, they can be geometrical defects, they can be radiometric defects, they can be noise defects. Okay, so these defects have some correction. Okay, like you can correct it by some putting up some line and changing the area of that particular thing. Okay, the radiometric effect can be changed by having a different reading with a different atmosphere effect. Okay, the noise removal is simple. Remove these types. Okay, remove this type, remove the bit of errors. Okay, you can remove the noise into the image. Okay, like noise removal, like this is an example of noise. Okay, this is a noise. Okay, this particular clouds are the example of having a noise into particular image. Okay, geometrical and radiometric correction is like let's say if you are having a image which is like this. Okay, this particular patch is an image. Okay, so you're not having a fully image, like this particular surface is not fully covered. Okay, so this is a geometrical error. Okay, so what you will do, you will increase the length of this particular thing or increase the area, so you will cover this particular patch. Okay, this patch, now white patch you are seeing now, this is white patch. Okay, this is white patch you will cover. Okay, now okay, so this is how geometrical error can be avoided. Radiometric error, the like atmospheric thing. Okay, you can avoid through this. Okay, so this is about the raw image which you are getting, and you can correct it. Okay, you can correct it through geometrical correction, you can correct it through radiometric correction, and you can correct it through noise removal. Okay, so geometric correction is very needed. Okay, for your raw digital image, because you want to have a very good image. Okay, you don't want to have an unstable image or any certain type of image. Okay, like this is an example. Okay, in which now I have included the paths. Okay, I forgot that part. Okay, yeah, so this is a simple example. Okay, like you are having a whole area which is you have captured through Google images. Okay, like you can find through Google Earth engine also. Okay, now you have to map the earth's like road connection, road network. You have to map the road network. So what you will do, simply you will map like this. Okay, this is the road network. Okay, and people will say there is a one cache over here, like this particular road is leading to towards the sea. Okay, and this happens naturally that some of the roads which you see in memes or something like jokes. Okay, that Google map is not showing correct direction. Okay, it is leading towards sea. Okay, so this is another example. This is a geometrical error. Okay, this you can avoid. Okay, this geometrical error you can avoid. Okay, so this is happening. Okay, this can happen. Okay, so this is a basic examples of geometrical errors. Understood, everyone? Okay. Now, let's move forward to the hyperspectral imaging. Okay, I will just give you a brief overview of hyperspectral imaging. Okay, one second. I have to present it in a different format. Okay, so till now there is no such doubt now. Absolutely everything is clear to everyone. Okay, so hyperspectral imaging. One second. So this is about hyperspectral imaging. Okay, so hyperspectral imaging is one of the best thing, okay, or the best technology which we have today. Okay, and what it does now, like we generally deals with RGB, okay, like red, green, and blue colors. Okay, but hyperspectral imaging, okay, hyperspectral imaging goes in much deeper way. Okay, much deeper way. Like in general, you have a frame. Okay, like you are capturing a data in just 3 frames, 4 frames, 5 frames, but hyperspectral imaging gives you a brief idea, 100,000 frames of a particular image. So you can study in a depth. Okay, you can study it in a very depth form. Okay, so this is how hyperspectral imaging is. Okay, I will show you a video also. Okay, regarding the hyperspectral imaging. So see, in RGB you are having 3 frames. Okay, red, green, and blue. Okay, in multispectral there can be 10 to 20 frames. Okay, but in hyperspectral it consists of hundreds of frames. Okay, with the different segments of RGB. Okay, with different segments of RGB, which provide you a different perspective to look at a particular image. Okay, like if you are running a hyperspectral imaging on myself, okay, you will be getting a detailed version of myself. Okay, like even bones will be able to study. Okay, like my bones, my jaw structure, my muscles, my tissues. Okay, each and everything on my skull is easily able to study. Okay, so this is the power of hyperspectral imaging. Okay, guys. So yeah, okay, I have a video for this. Okay, let me just present a video for this. Okay, so you guys can get an idea. One second. Let me know if the video is audible or not. Okay.
If you've ever used a camera, then you know something about spectral remote sensing.
It was audible, guys. Okay.
Spectral related to the electromagnetic Parameters produce what are called multi and hyperspectral remote sensing data. Multi
Of this session or what?
The video I have played now, this one.
अच्छा उसका link. Okay, sir. If you can share the link with me, then I can hand it out to the participants.
So I am sharing two video links, okay? Like you guys can watch this, okay? And the PPT I will share with the Vidhi, okay? She will share with you guys, okay?
Yes, sir. I will share it with everyone. So, sir, I would also like to thank you for taking out the time and conducting this session. Satellite imagery is certainly one of the topics that is very intriguing, but is not covered in the course or in the syllabus of any branch at all. As you have mentioned that this is a branch that involves almost all the branches, be it civil, mechanical, electrical, electronics, and it was a really insightful session, and I hope everyone else has enjoyed this session as much as I did. So thank you so much again for taking out the time for conducting this session.
I hope guys you enjoyed it, okay? And yeah, this is just exploration, okay? After this session now, also if you want to study about more about remote sensing, there is a website of let me share that website, okay? It is by Canadian government, okay? So that website can be very helpful for you, Canada Center for Remote Sensing, okay? Just go through this website, okay? You can learn a lot about remote sensing in a detailed format, okay? Okay, so this is the website, okay?